X, Y, Z, M, A, E, P. Okay, so what we have here right now is, so if we break MAE, MAE is the, if I was to open this in Google Chrome, it'd be better. Open. Okay, so MAE, okay, MAE, it's going to be equal to the absolute value of y hat minus y. You guys remember that?
Yeah.
Okay, so what we're gonna do is we're gonna divide it into a piecewise function where if you take a look over here, if y hat is less than y, this is gonna be what it's equal to. Because if you look at a graph of an absolute value function, so if you take the absolute value of x, what happens over here is any input that is greater than 0. So if y hat minus, so because the input into this function is y hat minus y, if y hat is greater than y, what's gonna happen is that we have a positive input, okay?
Okay.
Okay, so if we have a positive input, then by the absolute value function that equals the same amount. So if you input a 5, it's a 5, right?
Okay.
But then on the other side, so what we did was this part, the middle one. But then if y hat is less than y, what happens is that we have a negative input, right? Oh, sure, I wasn't. Okay, so we have a negative input, right?
Yeah, what about it?
Okay, so since we have a negative input, what happens is that we need to negate it again. So a negative input would result in a positive input, right? Output, right? So negative input results in a positive output, right?
Yeah.
Okay,
Wait,
so
what? Negative would what?
Aiden, why does your voice sounds like Ian?
Because I'm Ian.
And why does it say Aiden Cho?
It doesn't say Ian, it says Ian Kim.
Oh, bro, you changed your name. Come on. Where did Aiden go?
Did you not see the Discord? He had to go eat lunch.
At 11? What the heck?
Yeah,
Okay.
he eats early. He eats dinner at like 4. So
Okay, so okay, so since that's the case, we got a negative. So we gotta negate this, right? We're gonna negate the difference, right? Right?
what do you mean by negative? Like make it even?
Yeah. So if y
Okay.
hat, so let's say y hat right now, okay?
Uh-huh.
Let's say y hat is like 3, and then y should get this. Okay, and then let's say y is equal to 3.
Uh-huh.
Let's say y is equal to 5. So if you do y hat minus y, it's technically 3 minus, which you get -2, right? But then -2 error doesn't make sense because error can't be negative. So then what you end up doing is you make it positive by the absolute value, which is technically saying you do this, but then you put an extra negative right in front. Okay? Okay?
Yeah.
William?
Yeah, sorry, I was just talking to my mom.
Okay, so
Come on, Lucas.
okay, so if they're equal to each other right here,
Wait,
your
does this only
cost of-
work if y is equal to 0? Because
what?
hold on, let me think about this. Oh, never mind. It's gonna work in all cases.
Yeah. So this is the piecewise function that we get in the end, because if y hat is equal to y, then that means y hat is the prediction and the correct answer is equal to the prediction. That means you did everything right. So why would you have an error? So that's why you have 0 for the error over here. So if we were to go through each of these, like if we were to take, if we were to find the numerical derivative using this, you know epsilon, right? Epsilon is a tiny, tiny small number, right? So if you have a tiny, tiny small number subtracted by another tiny, tiny small number that's on the opposite end. So like if you have a point like, if on the graph you have a point like 1, 1. So what happens is that you use a tiny interval in this, can I? Oh shoot, what? Okay, whatever. So you have a, so what you have to do is to have a tiny interval because on this graph, if you zoom in to the graph, you get a linear line, and then you can calculate the slope using that tiny interval. So if you go through the algebra, what you end up getting is this. So the slope at every point is going to be -1 if your prediction is less than the correct value. And then if your prediction is greater than your actual value, then you get a slope of 1. And if they're the same, then the slope is 0. And over here, this is the case because if your weight, if you have the same prediction, then would you increase or decrease a parameter if they were the same? If you got a prediction that is equal to the correct answer, would you?
I heard you. I still remember what I said last time I was here. So Ian, you can answer this one.
Okay, so it's because when they're equal to each other, you got the correct, you predicted correctly. So if you predicted correctly, then you wouldn't need to increase or decrease the weight, and then you have 0 for the slope. And then this is technically the same thing because if you look on the graph, you have a when your input is negative, your output is a straight line this way. So, and then this straight line slope is -1 every single time. But then when you are greater than, if your prediction is greater than the actual answer, then you have a slope of 1 and it's another linear line. So that's why you get these values. Okay. Okay.
Yeah.
Okay, so now we are gonna, so now that we know MAE, so now if you go back to this board, we already got this part done. Okay. So and now we are gonna go to the next part, which is this part, this graph and this graph. Okay. So this is where I didn't get to last time. Okay, so to get that stuff, we are going to need to okay, so I'm gonna just use this again. Okay, so I'm gonna use this again, and so we got, okay, so if we come over here, what happens is that you take a tiny interval again. Let me move this up. Okay, so you take a tiny interval again. Okay, and then here's the function. You input xw, that's increased by a tiny value epsilon. And then here you have the bias, then you subtract it again. Okay, subtract it by another one on the opposite side of the interval. And then you substitute that, which is xw plus b, but then you have the epsilon in the way. And you simplify all the way down and you have x. So the reason why we get x such an easy value is because if you think about y equals mx plus b, right? So if you have y equals mx plus b. What is y?
Output.
What is m?
Huh?
M.
Oh, M slope
Okay, what is x?
input and
And what is b?
offset.
What?
Offset.
No, it's y-intercept.
Oh,
Okay, so
yeah.
if so our equation has became wx plus b, right? So if you think about w in terms of x, so if you replace w with an x and x with an m, what you get is xw plus b. And over here, x is the slope because you have replaced x with m and w with x because it is in relationship to w. Okay, you're trying to, oh shoot, you guys didn't see. Okay, so you were trying to find the relationship in respect to w. Okay,
Mhm.
so your slope is x. Okay, for the bias, it's really easy. What you end up getting is just 1. And the reason for that is because if you slightly increase b, so if you increase b by, let's say, if you increase b by 1, how much is your output going to increase by?
1.
Okay, how about if you increase the bias by 2? How much is your output going to increase?
Pretty much 2.
Okay, so as you can see, if you change the change in y hat divided by the change in b, so y hat changes by 2, you get 1. Over here, the same thing happens where you have 1 over 1, which is 1. Okay.
Hmm.
So that's why you have a your slope is 1. Now that that's done, so here is the code. Okay, so the code for this